The International Panel on Climate Change has an immense and important task. On the one hand, in assessing all the scientific information to understand climate change, and on the other hand, the communication of the science to us all and to the policymakers. The next speaker has led the work with the last report from the IPCC. Ladies and gentlemen, please welcome Professor Thomas Stocker.
Thank you very much. Good afternoon, ladies and gentlemen. It's a great pleasure to be here in Oslo, to be given the privilege as a scientist and co-chair of the first working group of the Intergovernmental Panel on Climate Change, to tell you firsthand what we found out in our assessment of anthropogenic climate change, an assessment that has been carried out over the past 4 years. I shall also take the opportunity to inform you what is behind such an assessment, because oftentimes in media I read these are just a few scientists who have an agenda and inform us not in a very objective way. Nothing could be further from the truth. I'm giving this talk on behalf of 259 authors from 39 countries who have worked in the past 4 years on this report. It started in 2008 when the leadership of the first working group, the Physical Science Basis, was elected in Geneva at a plenary meeting. A year later then, a group of government representatives, stakeholders, and scientists outlined the content of our assessment. In other words, they laid down that we want to know more about what we observe regarding climate change, about what we understand on recent climate change, and, the most important point, how the climate will develop in the future. Once this outline was approved by the governments of the world in 2010, we have selected 259 authors from over 1,000 nominations by governments and stakeholders. These authors were given the responsibility to assess the science that has been produced in the past few years that inform us about climate change. An assessment carried out by the Intergovernmental Panel on Climate Change is a very complex undertaking. We produce a succession of draft reports which are available for worldwide review. In these 3 years, we have received 54,677 review comments by over 1,000 experts worldwide. Each of these comments had to be responded to in writing, and action, if appropriate, had to be taken in revising the document. At the end of this process, we have now an assessment report, which is one of 3 assessment reports that the public will see in the next 6 months. There are 2 other working groups, Working Group 2, which is concerned with impacts and adaptation, and Working Group 3, which is concerned with mitigation and technological transformation. At the moment, these 2 other working groups are still in the process where they are waiting for the arrival of the last review comments by the governments on their top-level documents. So it's only about our assessment from Working Group 1 that I will present to you today. The assessment consists of 14 chapters with over 1 million words. As an innovative element in our report, we have an atlas of regional climate projections, in which 37 regions are investigated all around the globe, and we give changes in temperature and precipitation as they are expected, depending on so-called emission scenarios, or in short, depending on how much carbon dioxide is being emitted in the coming 100 years. Obviously, 1 million words is hard to communicate. Only specialists will actually read only parts of our assessment. That's why we also produced a summary for policymakers, which consists of 1,400 words. So that's like you take a wine that doesn't have a lot of alcohol and you distill quite heavily into a good product that has the essence in it in only 14,000 words. But 14,000 words is still a long document. It prints on 30 pages. And you cannot hope that a busy minister would actually read this summary for policymakers. That is why, for the first time, IPCC has decided to carry the communication one step further, and we have crafted 19 headline statements which are short, concise, and quotable. And these 19 headline statements, they summarize our 1 million word report into just 1.5 printed pages. And here I still have the hope that some ministers would actually read that document from top to the bottom. I want to take the opportunity here to tell you a little bit about these headline statements. I do this in 3 parts. We first look at the observations. What have the scientists learned when observing the climate system? And that's not just measuring temperatures in the atmosphere. It's observing the ocean. It's observing the glaciers, the ice in the Arctic, in the Antarctic, on Greenland, and the land surface, and many other elements of the climate system. I then go on to the understanding, and finally I come to the third part regarding the future. This is arguably one of the central time series in climate research, and it's very close to my heart because much of this data we have measured at our institute at the University of Bern in Switzerland. It shows you the variations of the most important greenhouse gas after water vapor in the atmosphere as reconstructed from an ice core from Antarctica over the past 800,000 years. And you see in the blue curve that there are natural variations of this concentration. So carbon dioxide was never really constant. But what you also see at the end of the curve is that this concentration has increased. These are the direct measurements from the atmosphere as they are available since 1958, just pasted onto this graph. You might now wonder how scientists can reconstruct carbon dioxide concentrations from the atmosphere over such a long time. This is done by analyzing ice cores, which we get from Greenland, but also from Antarctica. These ice cores contain air bubbles, and these air bubbles are tiny samples of the air at the time these bubbles were formed. And it turns out that we were extremely lucky when drilling in a European project, the last deep ice core in Antarctica, that we found air as far back as 800,000 years. So put now these natural variations into the context of today, and we see 2013 is up here, way beyond the natural variations, in fact 40% higher than pre-industrial. And that led scientists to formulate one of these headline statements, which reads, the atmospheric concentration of carbon dioxide have increased to levels unprecedented in at least 800,000 years. I should mention, while this is a statement that is short, concise, and quotable, the true strength and power of this statement is the fact that all the scientists agree with this statement, and all the 195 governments that participate in IPCC have approved this statement. If we look now at measurements of the Earth's surface temperature, and we depicted this as a change over the last 112 years, the message is very clear. Over most parts of the globe, you see red colors, which means warming. But there are 2 points that I would like to draw your attention to. One is a blue area in the North Atlantic. The North Atlantic actually renders us an important service. It cools a little bit the atmosphere because that ocean takes up so much heat that it can overcompensate the warming that would otherwise happen there. The second area I want to point your attention to are the white spots on this map. That is the area where the scientists have no confidence in the temperature measurements that are available over the past 112 years, where coverage is low or where the quality is actually not apparent. It's unfortunate that over large parts of the Southern Ocean and Antarctica we have no information, because scientifically this would be an extremely interesting area, which would allow us to better quantify the heat that the ocean in the Southern Hemisphere takes up, just as the heat that is taken up in the North Atlantic. Looking at this picture and previous and other statements on findings from observations, we can reconfirm a statement that the scientists have already made in 2007 in the previous assessment reports. And that statement reads, warming of the climate system is unequivocal. Let me now move to the understanding. Why is it that we do see these changes and measure these unprecedented alterations in the climate system? If we look at the temperature changes worldwide since 1951, we can observe that approximately 0.6 to 0.7 degrees Celsius, the world is warmer than prior to 1951, as you see here in the black bar at the top of this graph. The question now is, which processes actually are responsible for these 0.6 to 0.7 degrees Celsius? And it turns out that there are various possibilities. But in the green bar, we notice that the greenhouse gases are responsible primarily for the warming. In fact, they would warm the planet even more by about 0.9 degrees Celsius over these 60 years. So there must be also processes that cool the atmosphere, and they are generated by the dust concentration and the concentration of tiny particles that stem from the combustion of fossil fuels, so-called aerosols. And you see that in the yellow bar, that causes a cooling of about 0.25 degrees Celsius over that period. Together, the anthropogenic warming is almost identical to the observed warming, and that implies that the scientists are confident to make the statements, it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. Now, all of you have probably heard about changes in the sun, or volcanic eruptions, or internal variability of the climate system, often put forward by climate skeptics as the primary reason for the warming that we observe today. Now, the scientists have assessed that information based on peer-reviewed literature and have come to the conclusion that these processes that are given in the lower two lines of the graph are not responsible for more than 0.1 degrees Celsius with the associated uncertainty. Now, this, together with many other observations of rising sea level, of shrinking glaciers, of reducing mass on Greenland and Antarctica, have led to probably the simplest statement in our assessment, and that is the following: human influence on the climate system is clear. I can tell you I was a little bit scared when I chaired the meeting with the 195 governments in Stockholm just about a month ago, that this sentence would actually spark a broad discussion whether or not that is acceptable. After seeing and approving all the scientific evidence with numbers and ranges and uncertainties, the policymakers accepted this sentence within a few seconds. So this is now clear. Human influence on the climate system is clear. Let me now come in the remaining time to the future. Here you see the evolution of the temperature depending on two scenarios. A blue scenario, which is a policy intervention scenario, in the course of which greenhouse gas emissions in the 21st century are massively reduced. Opposed to that, a business as usual scenario in red that shows a warming by the end of the 21st century of over 4 degrees Celsius over the time period of the end of the 20th century. The mitigation scenario in blue, on the other hand, shows a warming of only about 1 degree. The scientists have put this observation, this model simulation result, I should say, into a policy-relevant context by relating that warming that the models simulate to a climate target that is being discussed at a different level of the negotiations, the so-called UNFCCC, the Framework Convention on Climate Change. And we say, global surface temperature change for the end of the 21st century is likely to exceed 1.5 degrees Celsius relative to pre-industrial for all scenarios except RCP 2.6. RCP 2.6 stands for this blue scenario. So unless there is massive reduction of greenhouse gas emissions, we are unlikely to reach the 1.5 target. Now, nobody lives in a global mean temperature, and you see here the maps depending on the two scenarios, RCP 2.6, the low emission scenario, and 8.5, the high emission scenario. These are two completely different worlds with a global mean temperature of only 1.5 degrees on the left and a global mean temperature exceeding 4.5 degrees on the right. We have a choice. It depends on our choices today whether the left or the right world will materialize. In particular for Arctic countries, this means the left choice, some remaining ice cover in the 21st century, second half of it, whereas the right scenario, the high emission scenario, business as usual, looks at very likely ice-free Arctic in September before the mid of the 21st century. I'd like to now show you an important element that helps policymakers to make informed decisions. And that is the recognition of the scientists that essentially the warming that we will experience in the 21st century can be estimated in simple terms by just looking at the total amount of carbon dioxide that has ever been emitted since pre-industrial times by humans. You see simulations in a graph where we plot on the horizontal these cumulative emissions, the totality of all the emissions, and the warming on the vertical, simulations up to 2010 over the 21st century, and you already see an indication of a linear relationship. If you now move forward into the scenario calculations covering the 21st century, you see that irrespective of the emission scenario, all these simulations lie on essentially the same line. The only way you can distinguish between the scenario is the point where you arrive at in the year 2100 for the blue scenario, which is the low emission scenario. You arrive at around 800 gigatons carbon in the year 2100 with a warming just below 2 degrees, whereas the red business as usual scenario goes right to the upper right corner of this diagram, which shows that these cumulative emissions now create a warming that is over 4.5 degrees Celsius. It's an astonishing finding by the scientists in such a complex system that consists of a dynamical atmosphere, ocean currents, a carbon cycle in which the terrestrial biosphere takes up carbon, all the plants, but also the ocean takes up a lot of the carbon dioxide emissions. And yet, such a simple relationship in this complex system. We say cumulative emissions of carbon dioxide largely determine global mean surface warming by the late 21st century and beyond. And you see that the scientists are quite conservative and careful, because we also communicate the uncertainties associated with our calculations, and they are depicted here as this red band. What you can now do in this graph is, if you define a temperature target of, say, 2 degrees Celsius, you go up to the 2 degree, make a right turn, go horizontal, look where the curve is, and that informs you how much the total carbon dioxide emissions are permittable by since the Industrial Revolution. Now, because of this budget approach, we are able to inform the policymakers very specifically by saying limiting climate change. So if you want to limit climate change, this will require substantial and sustained reductions of greenhouse gas emissions. Again, I remind you, this is a sentence approved by 195 governments participating in IPCC. Let me now look a little bit more closely into the 2 degree target. We say limiting warming likely less than 2 degrees Celsius relative to 1861 to 1880 requires cumulative emissions to stay below 1,000 gigatons. Now, what is a gigaton? A gigaton is a huge amount of carbon that is emitted. The world emits every year today around 10 gigatons. This means that we have a finite amount left until we violate the 2 degree target. And we inform until 2011, over 50% of this amount has already been emitted by industrial activity, including deforestation. In other words, if you make a very simple calculations, it's only a few decades, a window of opportunity that we have available as humankind to limit climate change to 2 degrees Celsius. And if you want to be a little bit more realistic and recognize that there are also other greenhouse gases emitted by us, such as methane or a nitrous oxide through agricultural processes, this allowable amount is 20% smaller, which means that time is even more urgent. Let me now close with this diagram here, this map of a quantity which I find as important as temperature when it comes to the discussion of global change. And that is precipitation. Arguably, water is the most important resource to humankind and ecosystems. And depending on the scenario on the left, we have moderate changes in precipitation across the world. That is not much different from the natural variations that we experience today. Whereas on the right, you see more intensive blue colors, which means more precipitation, up to 30 to 40% more. And in other areas which today are already challenged by drought and shortage of water, again, reductions of precipitations as much as 20 to 30%. Again, whether we live in the right world or the left world, this time the left is the low emission scenario, the right is the high emission scenario, it is our choice. Today, the choice of the global community, how much emissions will be brought into the atmosphere in the future. Thank you very much for your kind attention. Thank you.